Welcome back, class. Thank you for joining me for our next video. Today we are beginning 6-2, which is multiplying and dividing radical expressions. Now, before we begin actually multiplying and dividing them, I do want to take a little bit of time to just review how to simplify. Now, yesterday we worked with the idealized case, where everything could be taken out of the square root and everything was happy. Now, remember, from Expo, that's not always the case. Things can't always pull out the way that we want them to. So let's review, what do we do when something can't pull out the way that we necessarily want it to? Okay, so let's go over to 24. Well, 24 is not a perfect square. So if you recall, what we need to do is find the largest perfect square that divides it. So what I want you to do is, while you're watching this, please have out your power roots chart, okay? This is going to help you when going through your practice work, all right? So if you're looking at the power roots chart under the second power column, you can see that 4 is a perfect square. And in fact, that is the largest perfect square that goes into 24. So I can split up my 24 into 4 times 6. And then, as you know, the square root of 4 is the number 2. So this would simplify to 2 square roots of 6. Now, that same simplification process works for higher powers. All right, so let's look at the cubed root of 24. So now we're going to shift gears. Now we're going to look at that third power column. And in that third power column, what I notice is 8 divides 24. So I'm going to break this up into the cubed root of 8 and the cubed root of 3. Because this time, 8 times 3 gives us 24. So the cubed root of 8 we know is 2. So we actually simplify that one, and then we have to keep the cubed root of 3. All right, so remember, that's going to be our process for simplifying all these numbers, because that process works for any power. All right, you just break it up into the piece that pulls out and the piece that can't. So now here, I've listed some for you in your notes. However, the most beneficial thing to look at is going to be that power root chart that I gave you in class. All right, that's going to be the key to working these out. Now, I'm going to show you what to do when you have variables now. So, steps to simplifying. So now we're going to start with this example here. Okay? Now, the way that I start is by looking at the number. All right? So 54. So I'm looking at my power root chart in the third power column, because this is a cubed root. And I see that 27 divides 54. So I'm going to split up that 54 into the cubed root of 27 and the cubed root of 2. All right? So that's going to be the first thing that I do, pulling apart that perfect cube. Because now that 27 becomes this 3, and that 2 stays inside. All right, now what about the variables? Well, the variables, you start the same way as what we did yesterday. I'm going to say divide the exponent by the index, so by that n. And so what I want you to consider is in that fraction, so in this case, when you're looking at the x to the 5, when you're looking at that fraction, all right, however many full groups come out. So 5 over 3 is 1 with a remainder of 2. So that 1 actually is able to come out. All right? That remainder of 2 is the piece that's left inside. Okay, so you can think about the same thing. You're still dividing those two numbers, so 5 divided by 3, but if it doesn't give you a whole number, okay, if it gives you some remainder, that remainder stays inside of the radical piece. Same thing here, we're looking at the y. Well, I take that 6 divided by 3. Well, this time there is no remainder, so the whole thing just comes out. All right? So that's already a nicely worked out example for you. Okay? So let's work through an example together. Cubed root of 128 x to the 7. All right, so in my directions, I say the first thing I want to do is pull apart the number by a perfect nth power. So I'm going to pull apart that 128. I'm looking in that column, that third power column, and I see that that can be pulled apart into the cubed root of 64 and the cubed root of 2. All right? Because the cubed root of 64 is the number 4. So that cubed root of 64 actually comes all the way out, and then I'm going to leave some space to leave that. So I can write out anything else that's going to end up coming outside of my radical. All right, now I look at that x to the 7. So x to the 7, I think 7 divided by 3. All right, well, 7 divided by 3, well, that leaves me with 2, because 3 times 2 is 6. Then I have that remainder of 1, okay? So I can pull out 2 full groups of 3, but then I have 1 left over. So what ends up happening? Well, that 2 comes out with my x, so that is an x squared. 2 full ones came out, and then I have a remainder of 1 that is going to have to stay inside the radical. All right, and that is going to be my simplified radical expression. And that's how you're going to deal with all of them, okay? Split apart the number, divide the exponent, and then write accordingly. All right, well, the real emphasis today is combining them, so multiplying them. Now, the things that I do need to mention first are, when we're trying to combine these, the index has to be the same to do this multiplication process. So, notice these two. They have a different index, so they can't combine, okay? You would have to leave them separate. These two have the same index, so they can combine, okay? So just a little thing that you have to be aware of is to use this process, you need the same index, all right? Also note, to combine radicals, both radicals must be real numbers. So what that means, if n is even, neither one can have a negative number. So it's not like you can have two radicals with negative numbers to combine to be even and then take the square root. No, it doesn't work that way. If you have an even n, everything has to be positive, all right? So let's get down to the nitty-gritty of this. Let's actually talk about how do we combine these? How do we go through this process? Well, first step, to combine the expressions, multiply any numbers and add the exponents of any like variables. Remember, that's how we combine variables when we multiply. We end up adding them. So let's take a look at this. So it tells me multiply my numbers. So multiply my numbers to 720. And then on any like variable, I'm going to add the exponents. Wherever there isn't an exponent, remember, there's kind of a secret one there. So we're going to get an x to the 4 and a y to the 5. Beautiful. All right, now this is where that beginning stuff kicks in. So that simplifying that we just did, this is where it kicks in now. Once you multiply, now it's all simplifying from here. All right, now here, when we're trying to break up 720, you have to be careful that you find the largest perfect square that goes into it. So when you're looking at your powers chart and you're checking it out, you may see 36 and think, hey, 36 works. All right, I can divide 720 by 36. However, be very careful because, again, our goal is to find the largest perfect square that goes into it. And with our goal being the largest one, you would actually be looking for 144 and 5. 144 is the largest one that can pull out. So identify those two. Now the square root of 144 is the number 12. Then we have the square root of 5. So again, I'm going to leave some space there because I know I'm going to have to be adding in my variables now. All right, so x to the 4. So again, I'm going to take the exponent divided by my index, and in this case my index is 2. So 4 divided by 2 actually completely comes out. All right, now that the y to the 5. So y to the 5, well, if we think of 5/3, thinking of that, well, 5/3, 3 goes into 5 once, and then we have a remainder of 2 left. All right, so that remainder of 2, so a y comes out, and then with that remainder of 2, that's giving us a y squared that is left inside. All right, now, unfortunately, we're not quite finished. There's one more thing that we have to consider because we're dealing with an even index. We have to consider the absolute value of these. All right, so to finish off our conversation on this, the 12, remember, automatically comes outside of the absolute value because it's already a positive number. X squared, because when you square something, it's automatically positive. The y is the only thing of concern. So the y has to stay inside the absolute value, and then we have our 5y squared still inside our square root. All right, so continuing on. Now please make sure I have that written down because I'm actually going to erase a little bit of this so I have space for my next example. All right, so looking at our next example, again, our first step is to multiply the insides together. So 5 times 35 gives me 175, and now I add the exponents of my variables. All right, 175, if you're looking at your second power on your power chart on that list, you should see that 25 divides that. In fact, 25 times 7. So that means my 5 comes out because the square root of 25 is the number 5, and then 7 is stuck inside. So now let's look at my variables. X to the 6. I take that 6, I divide it by the index. Well, that means x to the 3rd fully comes out. All right? And now, the piece that doesn't, the y to the 7. So I take 7 and I divide it by the index. Well, that leaves me 3. I have 3 groups of 2. And then I have a remainder of 1 to get me up to 7. So I'm going to have y to the 3rd coming out. And then I have a y to the 1 that's stuck inside. But again, here's an instance that we are taking an even root. Okay, our index is 2. So that means everything that pulls out, we have to consider the absolute value. So the number comes out, but then notice, x to the third, y to the third, they're both odd powers. So both of them could end up with a negative number. So this time, both of my variables actually have to stay inside the absolute value, with the radical still tagged on at the end. All right, so let's do our last example before wrapping up. Now, what I want you to get from this last example is that when you have numbers outside the radical, multiply them separately and then keep them outside. So we're going to multiply the outsides and keep it outside, and then multiply the insides. So 5 times 4. Well, 5 times 4 gives me 20. And now let's worry about the insides. 2 times 32 is 64. And now I add my exponents. So that's what I get just with that multiplication process, okay, with combining the two radicals. Well, now I have to consider what comes out. Well, the neat thing here is that 64 is actually already a perfect cube, okay? So the 64 just comes right out. Now that 20 stays outside with it, so I'm just going to show that 20 is still multiplying out front. It's multiplying whatever else is coming out. All right, x to the 3. Well, I divide my exponent by the index, so that just leaves me with an x to the 1 that fully comes out. And now 5 divided by 3. Well, 3 goes into 5 once, and then there's a remainder of 2. Still 2 left over to get up to the 5. So that means I still have a y squared that is stuck inside that radical. And then finally, if you notice, now that I have these two numbers outside, 20 and 4, those can actually multiply to give me 80. So the final step in simplifying this is combine anything that was already outside with what came outside. And then that is going to be our final answer. And notice in this case, I can ignore the absolute value because we were dealing with an odd radical. So I don't have to worry about dealing with absolute values in this case. All right, so I believe that's enough notes for you today. This is kind of a beastly section. So we're going to call it good. Please make sure before you stop this video, make sure you have everything written out. And then tomorrow, be prepared to come back and do our practice work in class.